Yes folks, how are you going? Hume again. In this video we're going to continue with our series on indices, and we're going to look at what I refer to as rule number 8 according to my categorization, which, as I have already described, is a little different to what you will get in most textbooks. So according to my rule number 8, we have that a to the power of minus n is equal to 1 over a to the power of n. Alright? Now, it looks pretty simple and straightforward written there. You look at it and you tell yourself, yeah man, that easy, I could do that. But as is the case with so many other easy things, looking at it and understanding it from a distance is not the same thing as executing it when you find yourself having to execute it. So we could dive straight into some examples having said that. So consider the following. We know that 2 to the power of 4 is 16. Alright, I am deliberately using some powers here that we're probably not too familiar with, just so that it could leave a little imprint in your mind, just due to the fact that you would have seen it in this video here with me. And we also know that, where to write this by? We also know that, alright, let me stick with this for now. We're coming back to the next one just now. So we know that 2 to the power of 4 is 16. Yeah? What most people will do is that if they have to deal with 2 to the power of minus 4, they will say 2 to the power of minus 4 is minus 16. That is what most people will do. By the same token, we know that 2 to the power of 5 is equal to 32. And what most people will do in like manner is that confronted by 2 to the minus 5, they will put minus 32. And listen, nothing could be further from the truth in both cases. Because according to this law here that we're now trying to learn, 2 to the minus 4 is supposed to be 1 over 2 to the power of 4, which is 1 over 16. And 2 to the minus 5 is supposed to be 1 over 2 to the power of 5, which is equal to 1 over 32. Alright? So take 2 minutes and write it down if you want. Screenshot it. Use whatever method you use. But write these down, because looking at the examples, in fact, writing down the examples will help you to remember it better. And as we on that, let me just take 2 minutes out of this video just to highlight the point that even in this modern age of technology, we have all kind of thing. We have tablet and we have stylus and we have this and we have that. Some people feel that we don't need to write stuff. Let me tell you something. It might be old-fashioned, so to speak, but the physical act of putting pen to paper to write remains one of the best ways to program your body, to program your mind into something. Right? And one of the places where that comes in very handy is when you're doing maths. Because you see something, you learn it, you listen to it, you might read it. When you write it, it takes it to another level. And then, above and beyond just writing what you just learned, comes another level of writing when you have to do it as practice, as exercises. You have questions to do, you write it out. That's a whole different level of writing. So I want to take the opportunity to encourage you guys in this new age of technology. Some of the old things still work best. Another thing like that is reading a book, right? With all the Kindle and all the other electronic reading technology that we have, still can't beat back the good old-fashioned book. You have a book in your hand, you hold the book and you read it, right? There's so much we could say about that. That's a separate conversation, but I just taken a little time to slip it in. Yeah? Alright, so what I want to do is to examine some of the mistakes that people make and make it absolutely clear what the mistake is, so that you have a clearer understanding, so that if you yourself happen to be one of the people who make these mistakes, then at least you know why the thing that you was doing all the time is wrong. And hopefully that will help you to do the right thing all the time. So let us examine first of all the case of 2 to the power 16. So we know that this box in the middle here is the wrong box, right? Boom, bam, that's wrong. This here is where we start. We start with the positive powers and we build from that. So we start from 2 to the 4, and that will always be a reference point when you have to convert 2 to the minus 4. Right? Let me repeat that. When you're doing indices, your positive powers will always be a reference point. And that is why, just as is the case with the tables, where you learn your positive multiplication tables and then you use that as a reference point when you have to deal with minus. Right? 2 by 3 is 6, so you know what I write. 2 by minus 3 is minus 6, or minus 2 by 3 is minus 6, or minus 2 by minus 3 is still plus 6. Slightly different thing, separate video for that. I'm just making the point that your positive would always be a reference point. Same story here. 2 to the power of 4 is 16 as a reference point. So 2 to the power of minus 4, you know immediately will have something to do with 16. What a lot of people do is that they negate the 16. So instead of saying, so they move from 2 to the 4 equals 16 to 2 to the minus 4 equals minus 16, which is a reasonable mistake to make. Reasonable meaning that it makes logical sense. But even in mathematics, logical sense does not always mean that you have the right answer. There are still rules that you have to follow, and the rules may not always follow the logical thought pattern that we humans would employ. Right? This is a very good case of that. So we start with this here. This is a mistake here that most people would make. What is the mathematical explanation for that mistake? What people actually do is mistake this here for this. Minus 2 to the power of 4 is equal to minus 16. That is a mistake people are making. This is not this. So in other words, if you put the minus sign in front of the whole power, you negate the whole expression. And you do that by putting the whole expression in brackets with a negative sign outside. Then yes, that will give you minus 16. Alright? This is not the same as that. This looks right and it feels right, but it's not right. If you're putting a negative sign in front of the power, then that is an instruction to reciprocate, not to negate. Here, we negate 2 to the power of 4. Over here, we reciprocate the 16. So in other words, a to the minus n, you take your a to the power of n, which is your reference point, and you flip it. A to the minus n means you're moving from a to the n to 1 over a to the n. That is what the minus n stands for. Alright? So that is what happens there. That's the first mistake. This is the first explanation for the mistake. The second explanation for the mistake, and I wanted to watch this one carefully, is that if we negate the minus 2 alone, so in other words, we negate the base. We deal with that in other videos too. We negate the minus 2 alone, not the 4, or the whole thing as we did here. We take minus 2 in brackets to the power of minus 4. In this case, what a lot of people will do, they'll end up with minus 16 here, which again, it makes logical sense, but it's still wrong. Because even here, minus 2 to the power of 4 is not minus 16, but actually plus 16. That is a whole video by itself, which we will deal with another time. I'm just putting it here just to make the point. And I will draw the contrast between this and 2 to the power of 5 in a little bit. So stay tuned. So in both cases where people lean on their logic, you do this or I do this, and you're still wrong. Because the answer is actually this guy here, up in red. 1 over 2 to the power of 4. Same story with the 5. We change this 4 to a 5. So minus 2 to the power of 5 is actually equal to minus 32. So again, people will do this. 2 to the power of minus 5. What you're actually doing is confusing this with this. And you get minus 32 and you tell yourself it's correct. But no. Minus 2 to the power of 5 is minus 32. Because 2 to the power of 5 is minus 32. No problem. The other thing too is if you take minus 2 in brackets and you raise it to the 5th power, in this case you will also get minus 32 as the answer. So you have two instances here where you could end up with minus 32 as the result of processes that are different, have nothing to do with this. 2 to the minus 5 is not the same as minus 2 to the power of 5. Is not the same as minus 2 to the power of 5 in brackets. Totally different things. 2 to the power of minus 5 is 1 over 2 to the power of 5, which is 1 over 32. Alright? So you have to be very, very, very clear in your mind. Anytime you see a negative index, you're not just putting a minus sign in front of whatever your answer would have been before. You're not negating. You're reciprocating. What you're doing is flipping whatever you had before. Alright? Big difference. You're not changing the sign, you're flipping. Alright? So from 2 to the power of 4 equals 16. 2 to the power of minus 4 is 1 over 2 to the power of 4, which is 1 over 16. From 2 to the power of 5 is equal to 32. 2 to the power of minus 5 is 1 over 2 to the power of 5, which is 1 over 32. Not this, not that. Yeah? So that is basically it where the negative indices are concerned. I trust and I hope that you will take the opportunity to practice. Right? Hopefully you will have understood it a little better just looking at the video, but I want to underscore again the absolute necessity to practice. Right? Studying something is not the same thing as practicing it. You could study how to ride a bicycle, but until you get on a bike and start to ride, you haven't practiced it as yet. Right? And we know so many examples of things where the only way to do it, to learn how to do it, is not just to study, but to practice. And I want you to take that approach in your mathematics as well. So I trust and hope that you would have enjoyed this video, and I hope that you practice. Find the time, find the questions, find somebody to help you, whatever it is, get yourself some practice. Okay? Alright, so stay tuned. We have a few more videos coming up in this series of indices. We are not done as yet. Boom! Alright, so in this video, I want to consider a very special case of rule number 8. Remember in rule 8, we had said that a to the minus n is equal to 1 over a to the power of n. And we use a series of examples. But the one example that we didn't really give much serious consideration to was the example where n is equal to minus 1. Because when we let n equal minus 1, let n equal minus 1, what we end up with would be that a to the minus 1 is equal to 1 over a. And as simple as that result is, that is a powerful result. Right? This is a special case of the general rule here. And this is so important, that case where n is equal to minus 1, that on most scientific calculators, there is a whole button allocated to that. So on most calculators, you will see a button like this. You will see a button like this, x to the minus 1. That button is now your invitation on the calculator to invoke this rule here, which is a special case of this rule here. This is what we refer to as reciprocation. You reciprocate to find the reciprocal. Alright, reciprocation is not generally thought of. It is not generally taught. See the difference between thought of and taught. Right? It is not generally thought of. We don't think of it. T-H-O-U-G-H-T as an operation in mathematics. But for practical purposes, you could consider it as something that you could do, an operation. It is something that you can do when you're changing the subject of the formula, for example. You can reciprocate both sides of an equation to maintain the equation, etc., etc., etc. Which is the same thing as raising both sides of the equation to the power of minus 1. But we'll leave it alone for the time being. All we need to remember at this point is that a to the minus 1 is 1 over a, which is to say that we flip in a. Whatever it is a is equal to, we flip in that. That is what happens when you raise something to the power of minus 1. And that is what you will be doing when you press the x to the minus 1 button on a calculator. You're basically looking for the reciprocal. That is the noun from the verb to reciprocate. So if you reciprocate a particular expression in mathematics, what you end up with is the reciprocal. So let me do some examples just to demonstrate the application of this particular rule here. So for example, if I have let us say 5 to the minus 1. 5 to the minus 1 is 1 over 5. If I have 1 over 7 to the minus 1, that is equal to 7 over 1, which is the same thing as 7. See? Minus 1 is reciprocation. You're finding the reciprocal of whatever it is you're looking for there. Alright? And what about if we have different types of fractions? If we have, for example, 2 over 3 to the minus 1. 2 over 3 to the minus 1 is simply 3 over 2. End of discussion. And if we have 7 over 4 to the minus 1, that is simply 4 over 7. That is all. So in this case, your A is 2/3. 1 over 2/3 is 3 over 2. In this case, the A is 7 over 4. 1 over 7 over 4 is 4 over 7. In this case, the A is 5. So 1 over 5 is 1 over 5. In this case, your A is 1 over 7. So 1 over 1 over 7 is 7 over 1, which is just 7. And that's it, you know. That is it. So I take this out as a special case, one, considering that we didn't discuss it fully enough in the original video on rule number 8. But it also gave me the opportunity to address a very, very special and particular instance of rule number 8, which is the whole idea of the reciprocal. Anything to the power of minus 1 is a reciprocal. So we could do some examples using letters and things, right? Excuse, letters and numbers. So for example, you're doing a question and you come across, let us say, p to the minus 1. Well, p to the minus 1 is simply 1 over p, not so? Let us say you come across x over y to the minus 1. X over y to the minus 1 is simply y over x. You flip it. Right? And what about if you have xy in brackets to the power of minus 1? Xy to the power of minus 1. If your A is xy, that will just simply be 1 over xy. Yeah. So the nature of A is not important. Once you understand that all you're doing is flipping A, that is what we have here. A to the minus 1 is equal to 1 over A. Let me clear the board and write it over. Alright? Just to drive the point home that when you let n equal minus 1, then you end up with A to the minus 1 being equal to 1 over A. Yeah? That is it. So we introduced the rule in rule 8 in my series. Now we added a little addendum now, an appendix, so to speak, to rule 8, which is to say, when we let n equal minus 1, this is what we end up with. And we just went through some examples using numbers, using letters. We didn't do any using letters and numbers. Let me do our combo. Let me do our combo now. So if we have, let us say, s over 9 to the power of minus 1, and is simply equal to 9 over s. That's not a 5, that's a s. And if we have, let us say, 3t to the minus 1, that is simply equal to 1 over 3t. Yeah, see? Pretty consistent. Pretty consistent. That is what it is. So, hold on. So you have some examples, you have the rule, and that is it. So you have a fuller appreciation now of rule number 8, which is this guy here. And then when we take a special interest when n is equal to minus 1, there is a whole lot of applications in maths where we consider that particular case. But that is beyond the scope of this video. We just introduce the rule, we give some examples, end of discussion, and now with sufficient practice, you will be able to put yourself in a position where you could use the rule appropriately. So, go forth and practice. Yeah?